with dilations and ratios. We talked about this with regard to similar circles or dilations of circles. Okay, and dilations and similarity are going to fall hand in hand when we're talking about these ratios. Okay, and the ratios we're going to talk about with dilations or similar figures, okay, are the following. Okay, we discussed already that if the ratio of parts is given as m to n, then the ratio of areas for these same similar figures, so this is in similar figures. Remember, all circles were similar to each other, but these will be, as far as triangles are concerned, either dilations of a triangle form a similar one, or if you're specifically told you have similar triangles, then the ratio of areas is going to be that same ratio for every dimension being measured. So area measures 2 dimensions, and so our ratios will be m squared to n squared. And so what that would mean is if the ratio of parts is given as 2 over 3, then that means the ratio of their areas is going to be 2 squared to 3 squared. Okay, and these ratios will always involve or represent a conversion factor. So the conversion factor for areas is either going to be 4/9 or 9/4, all depending on whether you're looking to make something bigger, use 9/4, or smaller, 4/9. Okay. If I start by giving, or if it starts by giving you the ratio of their areas. So let's say you were given 81 to 64 as the ratio of areas, then you would work backwards. You could find the ratio of parts. What would the ratio of their individual parts be? 9 to 8. And once again, what that would represent is a conversion factor of 9 over 8 or 8 over 9, depending whether you're trying to move from something bigger to smaller or smaller to bigger. Okay, so I want you to see if you can answer these first 2 questions on the left. Okay, and then I'll talk through them, and then I'll have you try the problem on the right. But see if you can answer the 2 questions on the left. It's sort of the 2 applications of this relationship between ratio of parts and ratio of areas. In this problem, you're told that the ratio of parts between 2 similar triangles is 7 to 4. That means the ratio of their areas is going to be 7 squared to 4 squared. So your answer may be written as a ratio in this form. It might also be asked to be written as a fraction, 49 over 16. So those would be the 2 possible forms, and it should specify which one it's asking for. Okay, and this one you just leave as it is, but this does give you the conversion factor of 49 over 16 or 16 over 49, depending on whether you want to move from bigger to smaller or smaller to bigger. And the second example actually goes through that process to solve.